Hi, everybody. This is Joanne, and you are with us for Read Science. And I'm here today with my co-host, Jeff Schomeyer. And we will be talking with Carl Zimmer and talking specifically about his new book called She Has Her Mother's Laugh, The Powers, Perversions, and Potential of Heredity. And as you can see, it's a very large book, nearly 600 pages before the glossary and the references, and I'm so glad you could join us, Carl.
Thanks for having me.
Yeah, so Carl Zimmer, for those of you who don't know, well, first of all, I'll say if you've read anything about science in the New York Times and the Atlantic, you may have run across Carl here and there. But Carl Zimmer has written 13 books, I guess, including this one. This does not make 14, does it?
This is 13.
So we got a baker's dozens of books. And so Carl Zimmer writes the Matter column for the New York Times and has contributed to the Atlantic, National Geographic, Time, and Scientific American. He has won the Stephen Jay Gould Prize and many other honors for his journalism. And you teach science writing at Yale University. And some of your previous books include Parasite Rex, Microcosm, and Planet of Viruses. And I would have brought some of them out, but some of them are on my Kindle and some are on audio. And I saw Parasite Rex is on audio, right?
Yeah, finally.
Finally,
yeah.
Finally.
At long last.
Yes, we've all been waiting. Does it have edits?
No, I think they just kind of went with the original text.
Okay, all right. Even though it could stand an update maybe, right?
Every book can stand an update. Like the second it comes out in the bookstore, it's already out of date when you're writing about science, but that's life.
That's true. That's something you just have to accept.
Yeah.
Okay, Jeff, you want to throw out the first question?
Sure thing. Carl, you give us so many really fascinating stories in here, which itself is a topic. And I wasn't sure where to start, but I thought maybe with a top-level, top-down sort of view, because you promised in the subtitle that this is going to be about heredity. And I started reading, and I thought for a while, I was like, really? This is going to be about heredity? But I saw how you did it, and I thought it was brilliantly done by the time I got to the end, because you've taken the idea of heredity and made it large enough to encompass many different things that seem to fit naturally in it, if we're inclined to think that way, or if you guide us to think that way. So two things in mind that in a minute, maybe we can start talking about what this big idea of heredity is that you finally end up with. But I thought I wanted to start with that personal writing question. Where were you when you started doing research for this book on the idea of heredity? Did you have that rather narrow view that heredity was the genetics, or did you already feel that heredity was as big a topic as it was going to end up being when you wrote about it?
Well, I certainly was fascinated by heredity in the way I think we all are. You know, we look at our parents and grandparents and kind of wonder how we ended up the way we are because of them. And as a parent, I've started to think about my own kids and wondering about what they've inherited from me. And at the same time, you know, I was aware that as a journalist, that, you know, our understanding of heredity in terms of genes was really evolving incredibly quickly and in some profound ways, but that also that some scientists were arguing that we need what they argue for a broader theory of heredity. In other words, a heredity that could possibly encompass other channels like culture or epigenetics or the microbiome or other things that just a narrow focus on genes might be, we might be losing something. And so that got me interested in just sort of, you know, how heredity has evolved as a concept for over thousands of years and how it's continuing to change right now.
Because early on, when you talked about heredity, you were almost looking at it as a cultural thing. This is the way that estates get passed on and various cultural aspects. And then we talked, when you started talking about cows, and I'd have to find the reference someplace in my notes, but early on in the 18th century, the idea of cows as something that there was a bloodline and that there was a specific thing that happened. And then how at the beginning of the 20th century, it seemed that geneticists sort of said, nope, heredity is all about genetics. And then we're still trying to work our way out of that genetics is determinism kind of thing, which is pretty much where we were when I was in high school. And the picture has changed so much in the last 40 to 50 years that seems natural. But so it started out bigger, didn't it? And it went through this little narrow genetics picture. And now you feel like you give us lots of reasons why, if we're going to keep the idea of heredity, it's just has to be bigger.
Yeah, it's a big thing, and I mean, heredity does not equal genetics. I mean, genetics was discovered by people who were trying to answer that basic question of what is heredity, and I think it was a profoundly important discovery. But I still think that heredity is, by its nature, a broader thing. You can think of, I mean, maybe one way that I heard one scientist talk about heredity was the correlation between the present and the past. That's a little nerdy, but there's a certain poetry to it. Or you can think about what is it that the past has given the present, and what can the present hand down to the future.
Yeah, so it's like it's what we get from our parents or something. And I felt like just about as soon as I'd gotten to the point, maybe 2/3 of the way through the book, it's like, okay, I've got this picture of heredity, and we understand how we get all of this stuff from our parents. And then here comes this whole cascade of stories, which are utterly fascinating. I mean, the woman who was, on trial because her kids were not related to her. And stuff sort of begins to crumble to the point where you convince me. It's like, well, it's really tricky to talk about who our parents even are.
Yeah. I mean, you wouldn't think that until you start to learn about chimeras, and chimeras are these people who are basically combinations of cells start out in different individuals. And you might be talking about a woman who has cells from her children when they were when she was pregnant, and they can potentially spread through her body and end up in all sorts of places, including the brain. Then there are twins where one of the twins disappears, dies, or gets absorbed into the other embryo, and then you have someone who's born basically made up of these two populations of cells. And so that when these people have kids of their own, sometimes their kids don't match their DNA because their DNA is being tested from their blood, which came from a different individual. And so really, those decisions that I do start to any kind of simplistic view that heredity has to be a certain way, that it has to be a vertical transmission from one individual to another, and it always has to be that way. I mean, if that were true, chimeras would not be walking around.
Yeah, I was fascinated to see the way you started the story, because I have never heard of free martins before. To start in 1779, I made a note here of John Hunter, who discovered that there were cows, there were bulls, and there were free martins. And by the time that got worked out, we end up with the most amazing understanding of what really is going on. It was kind of spooky. But I was happy to learn about free martins. I think I can, get some free dinner out of that, maybe.
Yeah. Well, apparently they're good eating. So.
Well, that's what we said. And for people who, before you get to that page or something, free martins is where the story of chimeras and what they are and all starts out. Okay, Joanne, stop me there.
I know you've got more questions. So actually, as I was reading, a few names continued to pop up, as like in all good books, you pick up a thread that was begun before. So I'll just give you two names. Galton and Goddard played a very large role in this book. So you want to tell people about how you wove them in here?
Sure. So Francis Galton, you could argue that he was really the father of heredity, in the sense that he was really crucial in posing heredity as a scientific question that had to be answered. So Francis Galton, so he is born in the early 1800s to an extremely wealthy family, a family that actually made its money originally off of making guns, which were then sold to basically run the slave trade, so that tribes that were going to capture other tribes to sell to the slave traders would use Galton's guns. And then they shift into finance. And in any case, when Francis Galton was born, there's a lot of pressure on him to go finally to university and kind of bring that kind of honor to the Galton family, because none of them had been to university before. And he's quite a prodigy as a child. You know, he can recite ancient Greek at a very young age. But he gets to Cambridge and he wants to get the highest honors in math, and it just isn't working. And he uses all his money to hire the best tutors, and it still just isn't working. And he has a nervous breakdown. And when his father dies and he inherits this huge fortune, he just leaves. He gets essentially takes a gentleman's C, as it were, and leaves Cambridge without a kind of an embarrassing career there. But he was always fascinated by heredity, even at college. Like, why was it that the students who did really well at math seemed to have fathers or uncles, brothers who were really good at it too? He became convinced that there was something that was being passed down from generation to generation that was not money, but it was something else. There was what he would call hereditary genius. And he became more and more convinced that intelligence and height and all sorts of other characteristics of people were understood through heredity. And he actually invented some of the crucial original tools for understanding heredity. So, for example, he would make graphs comparing the height of children and their parents, and he would show that tall parents tended to have tall children, and short parents tended to have short children. And these were the first kind of correlations which scientists use today to study heredity. Now, he was so convinced about intelligence being purely the result of heredity that he became convinced that you could actually make society better by encouraging people with more genius to have more kids. And it was essentially just like breeding animals, like we were talking about before. And he called this eugenics. That's where the term eugenics comes from. And Galton was definitely quite racist and quite very much feeling that there was a certain sector of society that was superior to other sectors. But on the other hand, his view of eugenics was more wasn't as dark as eugenics would become later on, in the sense that he didn't want to kill anybody. He didn't want to sterilize anybody. He just wanted, the proper sort of people to have more kids. But all of these ideas, whether it's, about eugenics or about heredity or claims about intelligence, we still live with the results of all of that. So Galton is this huge figure that I think people don't really understand well enough.
Mm-hmm. It's interesting. And Goddard, on the other hand, was interested in sort of preventing feeble-mindedness.
That's right. That's right. Yeah. So I in order to really focus on where things went after the discovery of genetics, I decided to focus on this person, Henry Goddard, who's someone else who is not as appreciated as I think he should be. And so Goddard was a child psychologist, And in the early 1900s, he started working at a place called the Vineland Training School in New Jersey. And this was basically a home for the quote-unquote feeble-minded. And that's just a term that was used then to describe all sorts of different conditions. And Goddard was convinced that he could make a science out of child development and out of intelligence, and that by studying the children in Vineland and measuring their intelligence with some sort of precise measurement tool, he could understand the development of all children. And so he starts actually doing some of the first intelligence testing in the United States, and it's very successful. He starts to use it in regular schools. New York City has him start using it there, basically like calculating people's mental age compared to their chronological age. Mm-hmm. They want him to start inspecting immigrants coming in at Ellis Island because they want to only accept people who are of a certain level of intelligence, for example.
But then by the time he went through testing Army recruits with the Army, right, or military recruits, and discovered a lot of mentally undesirable people, then got to the testing of immigrants, and I made a note here that he was stunned, you say, that a huge proportion of the immigrants tested as feeble-minded. Italians, 79% of them. Jews, 83% of them were feeble-minded. Russians, 87% of them were feeble-minded. And you would think it might be hard to hold on to this idea after that, but he didn't seem to. He just seemed to think, oh, they must be sending us all their worst people, I guess. And and this proves it.
Right. And you know, so you take those results, and then what really became toxic in what Henry Goddard was doing is that he combined that with a sort of a newfound passion for genetics. So right around the time that genetics is starting to emerge in the early 1900s, he learns about it. He's contacted by a geneticist named Charles Davenport, who's wanting to do a study of the inheritance of feeble-mindedness. And so Goddard goes out and sends out field workers around New Jersey to interview the families of his students. And he becomes convinced that feeble-mindedness is this very simple genetic trait, which is just passed down, maybe like just one gene. And so he creates all of these pedigrees that he uses to claim as evidence for this. And he makes one student in particular, a woman named Emma Wolverton, who he referred to as Deborah Kallikak in a book, as sort of the poster child for eugenics, because he believes that these people, you know, who he's referring to with a term he comes up with called moron, these morons should not be allowed to have children. And so you can institutionalize them, he says, or maybe it's more efficient to get them sterilized. And he's a big sterilization laws that are starting to come into effect, and he lobbies for them in New Jersey and elsewhere. And this also leads to immigration policy, saying, well, we can't let these people from these countries in because their genes are going to drag down the whole country.
Yeah, dilute everything, and we'll have that crisis of a bad gene pool and all of that. And this whole thing, when I was reading this story, which just seemed to keep getting worse and worse and worse, it seemed like to me like an excellent parable of the dangers of trying to do science to prove what you know to be true, rather than to take what I would say a correct Popperian approach and try to disprove ideas, because they sure found a lot of things to bolster the notions that they knew had to be correct. Wouldn't you? You know?
Yeah, no, I completely agree, and you can see how a lot of these same attitudes already existed in the 19th century in the United States before genetics were discovered. You know, so that people say, oh, here's this degenerate family, and look at all the generations where they're criminals or freeloaders or so on. And all of a sudden, all this just got translated into the language of genes very quickly, very smoothly. But it all turned out to be the same, a miracle of miracles.
The whole Victorian great ladder of being was just there waiting for genes to explain why modern white Europeans are the superior group of people who are, deigned by God to rule.
Yeah, I mean, and sort of scientific concepts of race were emerging in the 16 and 1700s. And there, in those cases, scientists would focus on things that they could study, like the shape of skulls, for example. As soon as genes come on the scene, then some geneticists are claiming that, these genes prove that races are distinct and that you can rank them. That this race must have superior genes to this race. And so they leaped all these things, even though there are people, scientists and others at the time, who are saying, like, wait a minute.
Yeah, I was going to say, that's, it's a good thing to see. We have some heroes come in, and Thomas Morgan's like, I don't think so.
It ruled for a few hundred years. I had my real aha moment, I think, when you were talking about the emergence of race as an idea. And where are we? 18th century Spain. So everybody wanted to hate on the Jews, and then they decided, wait, if the Jews are a different race, then we can really hate on them, and it's objective. Basically, we just don't go around hating Jews. But then your observation that if you're going to identify Jews as a separate race, then the rest of Spaniards need to be a race too. And I thought, oh, that is a real pin drop moment, I thought, where it's like, yeah, you've taken this step, and now you're on that path, and it's just going to get worse for 200 more years before we start to get out of it.
Right, and it's very striking that in 1500s in Spain, there came to be these rules saying that you couldn't have any Jew in your family history, or forget getting that nice government job, or what have you. And so, but the problem was that all the noble families had Jews somewhere or another in their family tree. So they would hire genealogists to create these fictional stories of their past to sort of erase that. But what's striking is that you would just take finding one Jew to really just spoil the whole genealogy. And that carries over in the United States in terms of the one-drop rule, where one drop of quote-unquote black blood made you black in a legal term. And why it was somehow that would be so overwhelming, no one would ever really explain. But you do see those parallels that keep enduring century after century.
And just how long does it take to see the ridiculous when I'm reading, the South, the list of definitions of terms for each person who had a grandparent who was an octoroon and a grandparent who was a multi-moon, or what? I can't even remember all the names in order to define that. Therefore, you're in this level and you have a 3.7% amount of black blood. And so you're almost okay, but not quite. And very early on in the book, boy, it holds for hundreds of pages. You said, of all the powerful families in Europe, none worked as hard to keep themselves free of hereditary taint as the Habsburgs. And we end up saying, yeah, look what it did for them.
Yeah, it didn't end up very well for them, because they wanted to inherit all the power within their family so that their own children would keep inheriting this huge empire. And so you would just get into situations where uncles were marrying nieces. And after a while, what children were inheriting was a lot of mutations, a lot more mutations than you would find in other families. And it was incredibly devastating to their health. So that, in the Habsburg dynasty, after a while, the infant mortality rate was as high as in a peasant family, because these children were suffering all of these diseases, and there was lots of infertility also as well. So Heredity really came back with a vengeance for them.
But it's hard not to read that these days as a story, too, that comments on people's excitement about white supremacy and having their blood checked by 23andMe to make sure that they're mostly predominantly white, except for stuff you can ignore.
Right. I mean, I did not expect that this book would resonate as much as it is with the news. I totally did not have that in mind. I just thought that this was really fascinating history. But and the irony is that, you know, as we get to know our DNA better, these kind of simplistic ideas about what we used to call race just continue to disintegrate. You know, there's no, you know, if you find out you're oh, I'm 100% English, that's not like finding out that you're like 100% carbon or something like that. You know, the people in England are a community that was forged out of lots of interbreeding between very genetically distinct people over thousands of years. You know, so you have people coming in from Turkey and sweeping across Europe and showing up in England and basically pretty much wiping out all the hunter-gatherers who were there before, but still taking in some of their DNA. And then a few thousand years later, you have another wave of people coming from Russia. And again, there's this huge combination of DNA. And so what you can just the fact that you can recognize people's ancestry does not mean that you have like discovered, you know, the ultimate source and definition of people's being. Yeah. You've just found a group of people they're related to.
So when you're writing these days, how much do you feel the burden of trying to help people see that their ideas about what's fundamental defining science is really just a bunch of ephemerals? You know, it's just smoke that isn't really there. I was getting that feeling in here a lot, that you felt that there was a fair amount of responsibility to try to clear up some of these things.
Well, I think that, you know, there's just a lot of things that that are worth explaining and exploring, and you know, if people aren't familiar with how it was that scientists came to abandon these biological definitions of race, well, let's walk through it. Let's take a look at what happened. I mean, there were lots of debates about this, you know. I mean, in fact, you know, even in the 1940s, there were some biologists who said, well, you know, this early evidence really isn't lining up very well with these ideas of race. And some people say, like, well, that's true, but we can still call these different groups of people races. Let's just redefine the word race. And other people say, like, you know, race has such a long, horrible history, and people are just going to assume we're talking about the old definitions.
Yeah.
And I really like how one scientist put it to me now. He said, well, look, you know, the Greeks thought that there were 4 elements: air, water, earth, and fire. You know, and you know, we know that the air exists, so we know that there's a thing as fire, and it wouldn't make any sense to try to continue explaining the world with just 4 elements. It just it doesn't map on to the reality in a very meaningful, explanatory way. So you know, scientists themselves are saying, like, don't make us go back to, you know, these old ideas of race. It would be like telling us to go back, abandon the periodic table, and go back to the 4 elements of Greece. So let's not do that.
Right. Actually, I really appreciated that portion of the book, because I thought, I mean, you made it very clear, extraordinarily clear. Like, okay, this is how we used to, and this is now how we have to start looking at it, because we have more information in the concept of the genome, right? So now that we can sequence everything much cheaper than before, you know, we do need to modify our definitions. So I sort of have two things I want to ask. So I'll just start with one. So there's this general obsession with creating better humans in general. And now that, of course, we can maybe do that with CRISPR, you know, and, you know, things with pre-implantation genetic diagnosis and things like that. We seem to be particularly obsessed with intelligence, or maybe sports ability. So it's like, you know, we got both these things. You don't really talk about sports ability, but intelligence shows up a lot in here. So, and I like at the end of the book, you definitely start getting into the sticky ethical questions. You know, can we do it? Will we do it? So exactly what do I want to ask? So I'm curious because the general public thinks, oh, we can edit, so we can make intelligent babies. Like, why is it we're so stuck, like still with the one gene, one protein, one gene, one trait type thing? Is that just teaching, people not keeping up with the science? Is it sound bites? I mean, what do you think this is? What can we attribute this being stuck that, yeah, we can do that. We can make smarter people. Easy. Change one gene, right?
Right. Easy peasy. Well, I mean, I think, you know, we learn about genetics with Mendel, and that's all well and good. And you learn about dominant and recessive traits, and that's all well and good. But you know, if you're looking at, you know, a wrinkled pea like Mendel did, there really is just one gene that determines if it's wrinkled or not. It's just one gene. The problem is that a lot of times that's where the education stops when you're just barely getting started. And so, I mean, you know, when you talk about intelligence, there's a vast, wonderful, fascinating complexity to it that is really cool if you want to dive into it. If you're looking for simple answers, you'll be disappointed. So are there genes that influence intelligence? Absolutely. There are lots of them probably. And each one has a barely measurable effect, you know, a tiny, tiny fraction of one IQ point. And not only that, but these genes do not, you know, your IQ is not like fixed on what your parents' IQ was. You know, it can vary widely, and that's because of all sorts of different factors. It can have to do, for example, with, you know, were you exposed to lead as a child? Did your mother get iodine in her diet when she was pregnant? How much school did you have? You know, scientists have recently published a study showing that in places where they extended schooling by an extra year, they found an increase in these intelligence tests, these IQ tests of 1 to 5 points. So all of this goes into this great big mix of something that we label as intelligence, even if that's a kind of a vague term for it. And so the idea that you could say like, oh, okay, well, all right, tell me what letter do I change here to give my child super intelligence? Well, what do I do? That's really pretty absurd. And what makes it even more absurd is that it also, I mean, you know, like, so if I say like, well, but there are hundreds or thousands of genes that are involved here, people might say like, okay, we'll just change them all at once. And then you have to like explain to people, well, you know, CRISPR, the best they can do is just a couple genes at once, you know, like that's about it right now. Like,
right. And what if it's you know, some sort of enhancer or repressor that's actually more responsible than, you know, we're talking complexity within reading the genome.
Right. And have you actually identified the actual mutation that's relevant here, or have you just found a marker nearby?
And it doesn't control anything else.
Well, then there's that. Then yeah, I mean, exactly. I mean, these genes involved in intelligence, they do a number of things, and you start tinkering with them. Even if you do get an outcome that you want, maybe you're going to get other outcomes as well. So yeah, so that I agree that like people really are fixated on super genius babies, and I see that at least as an opportunity to really kind of bring people along and sort of talk about what we actually know about the brain and about intelligence and all of that. I think it's pretty cool, and even if it's going to I'm going to have to disappoint some people, I think it's worth it.
Yeah, I agree with that. I mean, and even the fact that some diseases we know, we have a gene, so PKU, which you go into detail, phenylketonuria. This we know this is one gene. Now we aren't fixing the genes; we're changing the diets, right, to help these kids. But then we look at diabetes or autism and things that we don't know all the factors that come into it. And I feel like, this is, that I still feel like, again, with these multifactorial genes that or diseases that we have this problem of people saying, but if we can just figure out the one gene, then that's it, job done. We're right. Set, right?
Yeah. It's this constant dream of a quick fix, and on the other hand, I do think that you're going to see gene editing lead to some pretty impressive cures for some diseases. Mm-hmm. So like sickle cell anemia. I mean, there are some trials that are going to be getting off the ground pretty soon where they're going to actually try to go into people's cells and edit their hemoglobin genes, and to try to get them to produce normal hemoglobin. And that could be amazing. That could be incredible. I mean, people with sickle cell anemia, it's a hard, rough life that's, at best maybe stretches into your 40s on average. And if scientists can give these people like a healthy, long life, that's fantastic. But sickle cell anemia is one of these diseases where you can zero in on one mutation. And, diabetes, you mentioned, is not sickle cell anemia. Right. And a lot more people have diabetes than have sickle cell anemia.
Yep. I have diabetes. I don't have sickle cell anemia. But when you were talking about the search for the genetic causes of height, was very interesting, because this turns out to be one of those very complicated things that, again, when I was in high school, would be clearly understood that there's a gene for height, because my high school times were very much embedded in the one trait, one gene paradigm. And it's been interesting for me personally to see that sort of disappear. And as my conversation started with like the only biology I knew. It's like when I was in high school, the question of cell differentiation was the top of the list of biology. People needed to know how these cells became other cells. And usually I end up expressing my opinion that what happened was not that question got answered, but the question got improved and turned into other thing after we understood developmental biology and all of these things. That no longer was an interesting question. But back with the height, you are quoting, I think, a scientist named Penrose, who says, some are taller, some are shorter, most were close to average. Just being short wasn't equivalent to having some kind of height disease. And this is the kind of ironic, support that I would expect for saying, humans are diverse, and maybe that's a better thing. And there is no group of people, I suspect, than the people I'm working around here at Gallaudet who feel that way about deafness. They do not see this as some sort of disease. This is not treated. And it's very interesting because I work in disability support. And one thing that we never accept here as a disability requiring accommodation is deafness, because everyone on campus is automatically accommodated. So it's not, and we have to talk about it differently when we go to a meeting someplace where that's not the rule. But I was very impressed by the idea that height is not some sort of, or being short is not equivalent to having a height disease. Need to see, but I don't know. you're going to have to write a lot to get through all of people's prejudiced notions, I think.
Oh, I agree. And, you know, I focus in my chapter on height on a scientist at Harvard named Joel Hirschhorn, who is also a pediatric endocrinologist. And he would see lots of patients, children whose parents were bringing them in because they were so worried about them being short. And, you know, Hirschhorn would have to say, like, well, he's fine. I mean, he's healthy. You know, there are diseases that are associated with short stature, but they're only associated with it. It's not in and of itself an issue. And yet, you know, you will see parents will really push to get their kids to receive growth hormone because they feel that, well, they're not accepted because they're short, or, well, that'll help them later in life if they're tall and sort of are accorded that respect. You know, those are all social issues. They're not medical ones. And, you know, the funniest thing was, like, Hirschhorn would say to these parents, they'd say, like, why? They'd say, why is my child so short? Yes. And he would kind of look at the parents and say, well, you're, no offense, but you're kind of short too. And yes. And then they would get into a discussion about genes and you know, like, because height was obviously so heritable that you could see these correlations, everybody just assumed that there were genes involved. And so the parents would say, what are these genes? And this was in the 1990s. And Hirschhorn would say, I don't know. Yes. I don't know a single one. And I think he said, like, after the 20th time, I thought, you know, maybe I could go and find them before I have this conversation again. But it took him, it wasn't until 2007, I believe, that he did a study that identified the first gene that's commonly present in people that influences height. And there was just one gene. And when he measured the effect, it was about like 1/8 of an inch. So it's sort of like putting on an extra pair of socks. And you know, but what's amazing is that since then he has he worked with other scientists to just get more and more people and look deeper and deeper into their genomes. And the last I checked, there were over 3,000 genes that they had, or 3,000 sites that they had linked to height in terms of heredity. So it's amazing. But it's hard to know when they might actually stop. I mean, because it may be that
everything contributes.
It's everything, which is kind of cosmic, but that's where they're going.
You think the easiest things to identify should have the easiest answers, and it never does.
It's just height. It's just a number. It's just you just take a tape measure. I mean, measuring intelligence is very complicated. I mean, first of all, there's the whole definition of what intelligence is, which is, you know, not settled. Second of all, it's like what are the best tests for it, you know, and there's debates about that. And then even if you agree on one of these sort of standard intelligence tests that psychologists use these days, it takes a long time to take that test, like half an hour. You know, you're not going to get like 1 million people taking the same half-hour test. It's just, that's not going to happen. Whereas it's very easy to just, you know, just say, okay, stand here, let me measure your height, and then we go on with the rest of the
and I think I had that height issue of mine when I was reading at the end, where we're talking about, you know, the brave new world of CRISPR editing and things like that, and thinking about ethical issues. And at one point I thought, do we really have so many ethical issues, or are they really more cultural issues? And maybe it's the same thing, but I thought, you know, there are an awful lot of cultural prejudices and preconceptions and all sorts of things. And it wasn't clear to me that there were, I don't know, obvious, clear-cut ethical issues that, you know, you don't immediately think of a counterexample or the sticky wicket to do thing. It just sounded more like, how long is it going to take to work through all of these things and get our culture to say, oh, I guess that was okay after all?
A long time, I think, because I think there's just going to be a lot of things that where those cultural values that we put on different aspects of our biology. I just don't see them going away anytime soon. I do think that the best we could hope to do is just to recognize when we think we are making some sort of objective statement about what would make someone better off when we're making a culturally loaded one.
Right. I was thinking, and this is very appropriate, you did this in the book, because you have here, she has her mother's laugh. You talk about your children and, of course, their mother, and you talk about how you were offered this opportunity to have your entire genome sequenced, not just 23andMe or Ancestry.com type thing where we're just looking for some markers. So, and of course, you talk about what you found most interesting in the book. I'd like to ask you to go ahead and reiterate some things you found interesting, but also did anything pop up where you thought, I don't want my kids to know this. I don't want them to have to worry about this in the future.
Well, that was certainly something that I was worried about in advance. I mean, I never having done something like this before, I was thinking about this, and I would talk to a genetic counselor about these issues. And I sort of had a wait and see attitude. Like, I wanted to write about this experience, but I didn't. If it turned out that there was some serious issue that affected not just me, but my children, I'd want to deal with that with my family. The journalism would have to take a second backseat to my family life. But when people get these sorts of tests, I forget the figure, maybe 10% will discover something where they really need to go talk to a doctor. They're like, okay, we have found this gene that you carry, you didn't realize it, that is a very serious, heart disease risk or cancer risk or for some other disease. I was not one of those people. And so, I just said, okay, full speed ahead. And what was really fun was to take all the raw data of my genome and go to scientists and say, like, let's look close with your expertise. And so, I went to Cold Spring Harbor and hung out with someone who studies Neanderthal DNA, and he looked really closely at the 1.2% of my DNA that I inherited from Neanderthals, maybe 50, 60, 70,000 years ago. And 23andMe will give you like a percentage number, but this was cool because I was actually getting a catalog. And so I could go look up these genes and be like, oh, interesting. Why do I have that? And what's that doing for me? Or how's that affecting who I am?
And for the rest of your life, you'll be able, as new things are discovered, you'll be able to go back and see if it's in your genome, It's true. Actually, what I ended up doing here at Yale, one of the scientists who helped me a lot, his name is Mark Gerstein, and he and his students did all sorts of analysis, and it was great. And at the end, he said, like, we should put this online, and because he didn't want all this analysis to go to waste. And then he said, and you should put your genome online too. Like, okay, well, let me think about that. And in the end, I decided to do that. And he has a class on bioinformatics. And for the past 2 years, they have one of the classes at the beginning of the course, and then they go and they look at my genome and they look for something interesting, and then I come back at the end of the course and they tell me what they found. So that's really cool.
Yeah.
So we've got Craig Venter and James Watson and you, all up online somewhere, right?
Oh yeah, no, it's if you Google the Zimmerome, Zimmerome. That's what Mark Gerstein called it. It was very funny. But so in this latest round, some students decided to take another look at my Neanderthal DNA, and they found one gene that is associated with toe deformities. Now, I've always thought my toes were just fine, and so and I also don't know why Neanderthals had bad toes. You'd think they need really, solid toes for,
Sure.
Good toes.
chasing after woolly rhinos. But there it is, another mystery.
But how does it feel to have someone say, oh, there is some Denisovan flow in Carl's genome? I thought that was pretty exciting.
Oh yeah. No, that was, it's the psychology of finding out about your ancestors is that in itself to me is fascinating. Why should we care? I don't know. But these Denisovans are these humans that we didn't even know about until somebody found a nondescript pinky bone and discovered it was loaded with DNA, and the DNA didn't belong to humans, didn't belong to Neanderthals, it belonged to another lineage of humanity.
Mm-hmm.
And it turns out that people in Australia and New Guinea and East Asia, to some extent, carry Denisovan DNA, probably because of interbreeding over there and sort of that part of Asia. My ancestry is not from that part of Asia, as far as I know, and yet it looks like I have at least a little Denisovan DNA.
There it is.
What was funny, though, is that the scientist said, well, here's what might have happened. Maybe some Denisovan and some Neanderthal had a baby, and then that Neanderthal Denisovan or their descendants then interbred with humans, and so that Denisovan DNA got sort of carried along the way. So I think that tracing all our DNA through all these different kinds of humans and interbreeding is going to be messy.
Yeah, sort of like, I think my physics background starts to get me interested with how geneticists and all the other people involved are able to piece this together to see about all of the paths of human migration for the last 2 million years. It's just, whoa, just amazes me.
Me too.
Yeah.
Yep, and so if you're a computer person and with any interest in biology, there's jobs out there for you,
Oh my God.
Bioinformatics is a big deal. I was intrigued, and I liked very much that you did this, that you added plants and animal examples, not just humans, but you did always manage to swing it back around to humans, because we're interested in ourselves. So how difficult was that for you, or was that easier than just hunting down Pearl Buck and these other human stories?
Well, I wanted to keep the focus on humans, but to remind the reader that we're just one species among many, and that we can't assume that the general rules of heredity that apply to us apply across the board. Heredity can be very weird in our own species in ways that, might surprise you, but it gets really, really weird in other species. And so plants, for example, are great because they're a really compelling example of this form of heredity based on epigenetics, where it's not the genes that are being passed down that matter so much as molecules inside the cells that are basically keeping those genes turned on and off. And there's really compelling evidence that plants can undergo experiences that change their epigenetics, and then their offspring essentially inherit changes due to those experiences. And that epigenetic inheritance goes down for several generations. It's really compelling stuff. Of course, then when you come, you come back to humans, and the question is, well, what about us? And everybody sort of assumes like, oh, we must have it too. The evidence really isn't compelling, but that hasn't stopped people from offering, epigenetic yoga and things like that.
Right. Yeah, I read a book. I want to say Bruce Lipton. He's a cell biologist, but then he just sort of went off into, but there's epigenetics, and that proves that our thoughts change our DNA. And I'm like, don't say that. We don't know that, right? And it just made my skin crawl a little bit.
Epigenetics just for some reason it makes people lose their minds, and it's,
yes.
I don't know why. And I've actually talked to epigenetic scientists who've asked me for help in understanding. Like they say, like somewhere around 2000, epigenetics just went crazy, and we don't know why. We've just been doing our research, and then people lost their minds, and I don't know what explains it, what the sociology of it is, but yeah, it's become downright mystical.
I think a lot of people were just waiting for an excuse to say, aha, Lamarck was right, Darwin was wrong.
Yeah, I think that's a fair point. And, if you look at in the Soviet Union under Stalin, Lysenko, Trofim Lysenko rose to the top because he was basically like arguing for something that is kind of like epigenetics, where he was basically saying like, well, if I expose these crops to certain conditions, like putting them in snow, I can permanently transform them, and that they will pass down these traits to their offspring, and the Soviet Union will become this incredibly powerful country. Instead, the Soviet Union had to start importing wheat from the United States. And now that epigenetics has sort of had this renaissance, there are people in Russia who say, aha, you see, Lysenko was right after all.
But not really.
Yeah, I know.
We can't make that leap yet.
But understanding why not really is one of the things that we're officially interested in here, Joanne and I, and that it shows how science actually works and how pseudoscience doesn't work. And there are many stories like that in here, which I found very satisfying.
Yeah, and actually, I know we're getting down to the last few minutes here. I'm just going to mention something. When I teach my classes, the things students seem to be most interested in, which I expect reflects also what the general public's interested in, are in your book. Things epigenetics, the microbiome, CRISPR. Like for sure, these are the top things people want me to explain. So I think now I can also hand them a book and say, hey, if you want to read, or maybe I should give them certain chapters anyway. I don't know. But yeah, good job including the, crowd pleasers. But important science, right? They're crowd pleasers because people want to know, and scientists and science communicators are saying, hey, this is cool stuff, and this is important, and this, raises more questions. We need to investigate more, right?
It is new and cool, but I think there's an aspect of, and those scientists don't know everything, so telepathy might still be true, and ESP works, and we see this as like, so I'm standing over here as the physicist person, and the thing that people get excited about and really want to talk to you about is scientists perplexed by possibility of new force. Really, it's not going to turn out that way, but whatever. And it's like, so see, it could be ESP. Yeah,
I mean, part of what makes it challenging as a journalist, it's challenging for me, is that some of the excitement about epigenetics, it actually comes from studies that are published in peer-reviewed journals, and they're fine for what they are, which is small studies with intriguing results. Statistics and small studies can lead them to just be wrong. And it's not anybody's fault per se. It's not like there's fraud involved, but if all the excitement is being generated from very small studies, and you're not seeing replication, and you're not seeing these things being scaled up to really big studies, then I think there can be a problem. I think people should say like, well, wait a minute, like that was intriguing, but that could be wrong. Where's the follow-up? Where's the real definitive research?
Very good. Well, Carl, we are so glad you came on. Is there anything you'd like to add before we say goodbye?
The one thing we
just well, I mean, it's a big subject. There are lots of stories in the book, and obviously there are plenty of things we didn't get to. And I just, leave it for, your viewers to enjoy all the rest just by reading the book.
So, enjoyment for the readers. There are so many stories that everyone will find plenty of things to fascinate them. Thanks very much for talking with us and for the book from my part.
Yeah.
My pleasure.
So everybody, we're really glad we had Carl Zimmer on, and She Has Her Mother's Laugh, The Powers, Perversions, and Potential of Heredity is available for you to get right now in all the formats. So if you don't want to carry a big book around, you have other ways to take care of it. Okay, Carl, thank you. Guys, we'll see you again next time on Read Science.
Thanks a lot. Take care.